before you can start using the database. All right. So let me just go through some introductory slides. Okay, just a little bit more information on the registration process. So they will ask you to accept a license agreement, and then you'll be required to fill in some information. For the email address, do remember to use only the university email. And you will then be prompted to create a username and password. So there is some requirement on what the username or password should be. So you can click on the tips link here, which will explain, okay, what's the criteria. And then when all that's done, you should receive a confirmation email from CAS. So go into the email, click on the link, and then you should be all set, all right? Okay, so today we're going to learn more about how to use the different features and functions in Scifinder N to accelerate your research to help you find information more effectively. So first of all, CAS is the organization that built the Scifinder N platform, and we are part of the American Chemical Society. So at CAS, we curate content from your patent literature as well as non-patent literature. We also include some other types of information from conference proceedings and dissertations, okay? And within the Scifinder N platform, there is also the Medline database. So in terms of scientific disciplines, we do cover a wide range of subject areas. From the more biochemistry, biomedical related topics, all the way to the more engineering, physical sciences, okay? And there is a very stringent process that goes on behind the scenes in putting together all this information. We have a team of scientists where, you know, their job is to actually read through the full text papers, whether it's a reference, a journal article, or a patent document. They read through the full text and they index information from it. So the type of information they will index includes things like the research topic that is being discussed in that paper, right? So the main research. They would also index important compounds or any chemical transformation that is reported in the paper. So in doing so, as a user, you are then able to do different types of search in Scifinder N. You can do a keyword search, you can do a structure search, you can even do a chemical reaction search. All right, so these are the different types of information you can find within Scifinder N. So for the demonstration later on, we will focus on these three main types of searches in Scifinder N. Okay, so now I'm going to switch over to the browser. Okay, just to see if there are any questions. Okay, no. Okay, so this is the platform of Scifinder N. So after you have created your own account and you log in, you should see this landing page. And on the left-hand side is the different types of searches that I've mentioned, right? So you have references, reactions, substances, and even a commercial supplier search. And at the bottom, you will also see, this is one of our latest addition into our search capabilities, which is for searching biosequences. So if there is enough time at the end, I'll also do a quick demonstration on this function over here. Okay, so we'll begin the demonstration by looking at reference searching. So for reference searching, typically people would put in the keywords, right, of the topic that they're working on to find relevant literature. Other than just keywords, you could also put in a specific compound name, or you can even put in a document identifier. Now, under the advanced search field, it's where you can do other types of searches to look for references. So you can begin with a specific author you're interested in. You can also look at publications from a certain organization. And you could also combine, for example, a keyword search with one of these other options over here. All right, but we'll do just a simple keyword search for a start. So I'm going to type in my topic. Okay, and this is the name of a plant. And you can see that as I'm typing, we get the drop-down list, which we can use to help check our spellings and also build the search query. So I found my desired topic, okay, and then just hit the search button. So what you will see in terms of the results would be a list of titles and abstracts, okay. So I have currently set my references to be sorted according to relevance. There are, of course, other options for you to sort your answer set. Okay, so because it's sorted by relevance, we will see kind of the more relevant hits appearing displayed or shown to us first. So if I look at, say, let me just kind of scroll down all the way to the bottom. So you can see all the different hit highlighting occurring in the title and the abstract. So I'll just go all the way down to reference number 15. Okay, it's over here. You can expand to see the full abstract. Okay, then if you want to know further information on this reference, click on the title of the article itself. This will bring us into the reference detailed view for this reference. So you'll get more information about the journal, the bibliographic information, the organization. And you will also see this section here called concepts. Okay, and we also see hit highlighting happening in the concepts section. So if you recall in the introduction slides, I mentioned that there is this process where the CAS scientists read through the full text documents. And this is one of the information that they index in that process. Okay, so basically these represent the key research topics that are being discussed in the full text paper. Okay, and then in the second section, you will also sometimes see the Medline medical subject headings. So I've also mentioned that in the Scifinder N platform, you'll get to search the Medline database. So Medline is built by the National Library of Medicine in the US. So it's not built by CAS, but we have incorporated that reference database into Scifinder N. So you actually get to search two sources of information. And the information that you see here, this is the indexing done by Medline. Okay, so again, we do see the hit highlighting occurring. So when you run a search, it's actually looking at the title, abstract, as well as all this additional information that the database analysts have provided for us. Okay, and finally, at the bottom, we also have substances. So this would be key substances that have been reported in the paper. So again, CAS analysts, we draw out the structures for you. We assign the CAS registry numbers. And then not only that, if you look more closely, I'm going to zoom in. There is this role information. So you actually have an idea how each of these compounds are being used in the paper. Okay, so for example, the second compound here, you see that there is a biological study role. So it's likely they've performed some biological study on this compound. You also see natural product occurrence. So this is something that occurs naturally in the natural products, okay? And then they looked at properties of it as well. And then if you see here, there's purification or recovery. So it's likely they perform some extraction of the plant and isolated the components from the extract, okay? So you get a lot of insights into the research that's being described in the full text without having to go into the full text yet, okay? And then at this point, if you decide that, well, this is really interesting for me and I want to go to, explore the full text further, we have the full text link here, but just bear in mind, okay, I'm going to click on DOI. to show you. This brings us to the publisher's website, but bear in mind from this point onwards, whether or not you can access the full text will be dependent on your institution's access to the individual publishers. So for example, I do not have access to Science Direct. So as you can see here, it's asking me to purchase the PDF, right? So I only get to see the title and the abstract. Okay, but the full text link will link you out to the publisher's website. And then finally, back to the structures again. So all the structure images that you see here, they're actually clickable. So I can click on one of the compounds and it brings up this fly out window. So in this window, it provides us with additional options to run further searches on this compound. So it could be looking up further details on this substance to find reactions involving this substance, or even creating a retrosynthesis plan to plan out a synthesis for this substance or other relevant literature and even commercial supplier. Okay. Furthermore, if you click on the CAS registry number here, again, if you're not familiar with the CAS registry number, it is a unique identifier for each compound assigned by CAS, and it's used globally across different industries as a unambiguous way to identify a compound. Okay, so I can also click on the CAS registry number to open up the substance detail page. And this is where I will be able to find information like properties, spectra, etc. All right, so we'll talk about substance detail in the second part of the demo when we look at searching substances. So going back to reference, so I've just kind of introduced the type of information you can get for each reference in Scifinder N. I'm going back to the initial answer set. Okay, so on the left-hand side is where you see different filter options. So this is what you can use to help narrow down your references to a smaller, more precise and more relevant set of references. So most of the filter options are quite intuitive, like document type, language, etc. So I'd like to bring your attention to the concept filter. So this is something that is unique to Scifinder N. So if you recall, I've shown you the Medline medical subject headings as well as the CAS concepts, right? So all the keywords there can actually be used to help us to find more relevant references. So if I open up this concept filter, you can see all the different keywords listed here. So these are the concepts and Medline medical subject headings extracted from our current answer set. Sorry. Okay, so the first tab, top count, tells us the most commonly occurring concepts. Okay, so our research topic is the name of the plant. So naturally, this comes up as the most number of references containing this concept. And then you see a very highly related concept, pharmaceutical natural product, because this is a natural product with pharmacological activity. Okay, so if you go down the list, you'll see all the different topics that are occurring commonly, which indicates that these topics are important in this research area. Okay, and we also see, for example, here, anti-inflammatory agents. So again, this gives us an idea that this plant likely has this sort of activity. Okay, and then I even see something like pharmaceutical tablets. So this likely would show me references where perhaps they are converting the Andrographis plant into a tablet form. So we can select this just to take a look. Okay, so I've selected pharmaceutical tablet, and then you can see right away now the references that we are looking. You can see it says here Andrographis paniculata tablets, This is also related to tablets. This is also related to tablets, okay, because we have selected the tablet concept. Now, the concept filter doesn't actually look at what is mentioned in the title and the abstract. Okay, so let me go in to the reference detail and you will have a clearer picture what I'm talking about. So the reason why this reference was retrieved for us, it's because you can see here, pharmaceutical tablets is listed as an important topic for this full text paper. Oh, and then if you look at this, it's actually a paper from Airlangga. Okay, so when we select the pharmaceutical tablet filter, it will retrieve the references based on what is mentioned in the concept section or in the Medline medical subject headings. All right, so I'm going to go back out again and let's explore further on this filter. Okay, so other than kind of looking through the top count to learn what are the commonly occurring concepts for your research area, you can also search for topics of interest, okay? So maybe you are curious to see, well, for this plant, did anyone report anything related to maybe cancer, okay? So in CAS, the concept used for cancer is neoplasm, okay? So I can search neoplasm and you can see that we actually see very specific concepts for different types of cancer. So this gives you a very nice overview, right, in terms of this andrographis plant, you know, what type of cancer have people actually tried to use the plant as a treatment option. Okay, and again, if I decide that, well, I'm interested in, you know, colorectal neoplasm, you see that there are two similar concepts, right? So that's because one is the CAS concept, one is the Medline concept. We can select both. Again, just to show you how the filter works. So you can see this answer set now, if you just look at the title, it talks about, you know, colorectal cancer or carcinoma. And even if you don't see it here, okay, mentioned specifically in the title or the abstract, remember, it's actually filtering based on what is in the concepts section. Okay, so we should see colorectal neoplasm mentioned here. All right, so this is the concept filter. And there are many other interesting things that you can learn from the concept filter section. Let me just open this up again. Okay, another, especially for the area of natural products and, you know, kind of drug discovery, another useful concept to search is agent, because this is typically used to describe something that has a certain bioactivity. So looking at this, you can also see the different types of bioactivity that people have tried to evaluate andrographis for, okay, such as anti-Alzheimer's, anti-aging, etc., etc. Okay, and you can also search for example, extraction, right? So if you want to learn what are some of the extraction techniques for extracting your components from the plant, if you search extraction, you can see that, you know, people have used microwave extraction, solid phase extraction, ultrasonic extraction, etc., or even chromatography. And this will actually show us all the concepts related to different chromatographic techniques. Okay, and another interesting indexing that CAS does for natural products, we actually index the part of the plant that paper is focusing on. So for example, we can search leaves. Okay, and then there will be a leaf concept here, or even root. So if you are interested in references that look at a specific part of a plant, you can also consider using the concept filter to help you find those references. Okay, STEM. So this is a very useful filter to use. And then of course, if you don't wish to use the concept filter, right at the bottom, we have another way to filter answers. And that is to put in your own keywords. So for example, if I'm interested to find paper related to Alzheimer's, I don't have to use the concept Alzheimer's in the concept filter, I can also just type out Alzheimer's. Okay, this would be another option. The difference is that if you do a search within results, it will actually search in the title and the abstract, not just the concept. All right, so we see additional hit highlighting now occurring in the abstract. Of course, if it appears in the concept, it will also be highlighted. So let me just check concept. So we also see the highlighting here. Okay, let's see for Medline. There's no hit for Medline. Okay, so the search within results works kind of like the initial search that we do. It will search the title, the abstract, as well as the concepts, whereas the concept filter is just focused on the concepts and the Medline medical subject headings. Okay, so once you are you've kind of done your search and you've done your refinement, you're happy with the search strategy, you may want to save this so that the next time you want to rerun the search, you don't have to reapply all the different filters. All right, to do that, you can click on the save button here. And while saving the search, you will also have the option to set up alerts for your search so that you'll be notified if anything is added to our database. So I'm going to give it a name. So angiographis, for example. Okay, and maybe I'll say as available and click on the save button. So whatever you save would go to this folder over here. Let me open this up and show you. Okay, so you can see that it has run, it has saved the search, including any filters you may have applied. And for this search itself, alerts have been set up. You can always change the alert format if you want. And you can always come back here to rerun the search with the filters applied. Now, if you didn't apply any filter, you don't actually have to save the search manually each time. There is a history, search history folder over here. So let me open this up. So you can see that, you know, the search that we have just run earlier on has already been automatically saved for us. And in fact, you can go back to, you know, months and months ago to find searches that you have run on previously. All right. So for example, 4th of June, I can click on 4th of June at the calendar, and then it shows me what are the searches that I've done on 4th of June. Okay, so this is automatically saved for the first initial search that we run. Okay, let me go back again. All right, the next thing I'd like to show to you in Scifinder N is pattern. So what we have seen so far are all these, they are journal articles. Like I mentioned in the introduction, we do have patterns as well in Scifinder N. So I'm going to use the document type filter and just select patterns. So this will immediately show us the patterns that are present in our current answer set. Okay, so for patterns, you notice that there is a second button here called pattern pack. So this pattern pack would allow us to access the full text PDF. Okay, we have up to 3 different pattern pack options. So I'm just going to open the first one here, the viewer option. The viewer option gives us the PDF of the pattern, like what we see here. In addition, it has this window of the key substances indexed from this paper, and there are page numbers to help us locate information in the pattern where each of these compounds have been mentioned. Okay, so if I click on page 16 here, you can see here it's this is andrographolite, right? So it has found this compound, and then this is the information around this compound. And if you come across any markers as well, you can also click on them. Okay, so let me just click on this, and it will show us what is the structure of the compound as well as the CAS registry number. And from here, from the structure window, right, if you come across an interesting compound described in a pattern, you can again click on the structure image, to pull out this window, which would then allow us to run further searches on a compound of interest. Okay, so this is pattern pack. Now let me go to another example. So we can also access pattern pack from the reference detail. So I'm going to click on the title to go into the reference detail view. Okay, so again, we have the different pattern pack options. Now, if you scroll down to the bottom, you notice that for these three substances, there is also a pattern pack icon. Okay, so this would be another way you can open up the pattern pack viewer. So I can click on the second, for example, the second compound. So when I do it this way, you can see it immediately show me the page where this compound is first appears in the pattern. So I don't actually have to scroll through the viewer to find my compound of interest. Okay, and then there are two other pattern pack options, PDF and PDF Plus. So I'll just open them up to show you the difference. So I think PDF, you know, it's just a plain PDF, right? So nothing different from just a regular PDF. And then the PDF Plus is also the regular PDF, but it has this substance table at the end of the pattern. Okay, so I'm going right to the end, and you will see a table like this that shows, again, the key substances from that pattern and with the page number information. So you can see this kind of like a offline version of the viewer. So if you need to read your patterns offline, you can still have access to the page information. Okay, so this is pattern pack. Let me just close these windows. All right, going back. So let us look at one more other topic. Okay, so I can rerun a new search from the top, the search bar here. I'm going to remove my previous query. And this time I'm going to look for references on helical, okay, pylori. And what if I want to have more than one keyword or search phrase in my query? I can use the AND operator. Okay, so this will ensure that both terms will be present in our answer set. So I'm combining this with another topic, drug resistance. Okay, and to be more specific, because there is no operator between these two words, so you may get hits where it contains only one of the two words in this phrase. So to be more specific, we can either insert additional AND operator here, but if you know these two always occur next to each other, we can use a double quotation to do a phrase search. For drug resistance, we can either put the AND operator or this will also work. Okay, so it depends how specific you want to be. If you want to allow some variation, maybe to have some words inserted between drug resistance, or you want to have resistance and drug to be present in a different order, then use the AND operator. Okay, so for this example, I'm just going to do the most specific one and run the search. Okay, and because right now I have a very specific search strategy, I know that all the references in my result set will have to contain all my required keywords. Not only that, but in the order that I have typed it in. In this instance, I would actually load the entire answer set. So if you noticed earlier, I didn't actually click on this button because we didn't use any operators to ensure a specific search. So I just wanted to, I didn't load the full answer set so that we only see the ones that are more relevant, okay? But once you have ensured that your search query is specific enough, then we can load the answer set, the full answer set, without having to worry about some noise that we may get, okay? So this is the full answer set. So the next thing that I like to show to you is the citation map feature. Okay, so if we just use the first example over here, you can see the number here tells us how many times it has been cited by other papers. If we want to see the references cited by this paper itself, we have to go into the reference detail view. The other option is to click on citation map. So citation map will allow us to see both the cited references as well as the citing references. Okay, so the ones on the right-hand side in green, this will be papers that have cited our root document. Okay, whereas the ones here would be the references that have been cited by this root document. And as I move up and down the different small circles, let me switch to the other one. Okay, you can see that it just moves accordingly. And if you want to view the abstract, because right now you only see the title and the bibliographic information. If you want to see an author information, if you want to see the abstract, just click on each of the squares, and this pop-up window will show us the full abstract. And then, of course, if you want to view the reference detail, you'll have to open this in the new tab. You can open this in the new tab, and this will be similar to what we were looking at earlier on with the concepts and any key substances. Okay. Within the citation map filter, we've also got different filter options. So sometimes, if there are many citations for this reference, it may be tedious to have to look through every single title and abstract to evaluate if it's relevant. So we can use any of these filters to maybe help us focus on the citations that are more relevant to our research area. So again, there is, of course, there are authors and other filters, but there is also the concept filter, similar to what we saw earlier on. Okay, and then looking through this, we can find references that contain the concept that we are interested in and focus on those references first. So maybe if I say, adolescent, okay, and then I hit apply. So you'll see that it is reduced to just this number of references that perhaps, focused on looking at this disease in adolescent population. Okay, so this is the citation map feature. Okay, so this is for reference searching. So I'm just take a quick pause to see if there are any questions. Let me take a look.
Yes, Pam. I think Prof. Nanik like to ask on how to check on whether their compound is new or novel. Just in case they do any synthesis or isolate them.
Yeah, okay, sure. So this will be covered in the second part of the topic where we go into substance searching. So if there's no questions on this, then let me just go, I'll move on, okay? So we've looked at reference searching. Then the next type of search we will look at is substance search. So again, with substance search, there are various ways to start a substance search. You could be looking up a compound just to find information around it. And of course, like what Prof. Nanik's question was related to, you want to maybe put in a chemical structure that you have been working on to see if anyone has reported on it, okay? So I'll first do the simple search, which is to do a search by substance name, okay? So let me just put in, I'm going to do andrographylite. So again, we can make use of this, and you can search more than one substance each time. So if I have a second compound, I can just type it in. So I'm putting in germanium oxide, run the search. So I have two compounds, but you might see, we actually have 5 hits. So two of the hits are actually contributed to the system trying to search germanium on its own as well as oxide, okay? But this would be the one that we are interested in. And then we also have andrographolite over here. So other than organic compounds, we also have inorganic compounds in our database, all right? So I'll just talk about what type of information you can find for compounds in our database. So we'll look at andrographolite first. Again, we can click on the CAS registry number to go into the substance detailed view. So if you recall earlier on, we did a crossover from references into this view. And this is where we can find all the information related to this compound, okay? These are different synonyms for the compound. And then these are experimental properties. So it will differ from compound to compound in terms of what type of property is available. You will also see that sometimes in the value column, it says to see full text, which means you have to refer to the full text document to look up the actual data point. And we have referenced every property accordingly. So you can find them here and then link out to the full text. So although it's an additional step, but at least you know which reference you can go to, okay? So in some cases, such as like density, you may see the actual value available within Scifinder N. Then we also have experimental spectra. Again, sometimes, we will point you to the document that you can get the chemical shifts for example, the NMR. In this case, the carbon-13 NMR is actually available within Scifinder N. So we can click on it to view the spectra. So this is useful, right? For example, if you have synthesized something or isolated something and you want to double check your spectra against spectra from the literature. And yeah, so if the link is not available, then you'll need to go to the full text to find it. And then for andrographolite and other pharmaceutical natural products or drugs, you will typically find these two other sections called bioactivity indicators and target indicators. So the bioactivity indicators actually kind of summarizes the different types of bioactivity that people have investigated andrographolite for in the literature, all right? The number that you see behind each bioactivity represents the number of references that have kind of looked at this association, all right? So you can see there's quite a lot of work looking at the anti-inflammatory properties of andrographolite as well as the anti-tumor property. Similarly, for the target indicators, it also summarizes the biological targets that have been linked to andrographolite in the literature, okay? And the number represents the number of references. So if you're interested to look at any of these targets or bioactivity related to andrographolite, we can always right-click and then open up. This would bring us to the 304 references. Okay, now if I go back up, you can see that you can also get a supplier. If you like to, for example, maybe purchase this in to do some testing, okay, just do a quick introduction to the supplier information. This tells us which suppliers sell the compound. You'll be able to see pricing information or stock availability information. And I have set some suppliers as preferred, so they appear on my list first. You can always click on the supplier name to find contact information for the supplier as well as any other distributors they may have, okay? And then of course, on the left-hand side are different filters to help you narrow down to the most suitable supplier, either by the quantity they can supply, or whether the thing is typically maintained in stock, etc. Okay, so this is supplier information. Let me just, what's this? Okay, I'll just close this first. And then there's also the option to link out to reactions. So if you like to maybe try to find out how to synthesize this, we can always open this up in another tab, and this will show us all the reactions that involve andrographolite either as a product or a reaction. If we like to synthesize andrographolite, we can limit it to the product role. Okay, just try it again. Let me refresh it and apply. Okay, so this will only show us the reactions where andrographolite is the target molecule. So we'll talk about reaction searching more in the last part of the demo. Okay, and then finally, we can also link out to literature, right? So this will give us references that talk about andrographolite as a research focus. So I open this up in a new tab. Okay, and because of this crossover from a substance, there is actually now a new filter available. So this filter is the role information, and we can use this to help us find references where andrographolite is used in a way that we are interested in. Okay, so let's wait for this to load up. So for example, we might be interested to see papers that look at the pharmacological activity of andrographolite, or where they perform analysis on andrographolite, therefore andrographolite has the analyte role, or it could even be synthetic preparation or biosynthetic preparation. Okay, so this could be interesting for those who are maybe exploring biochemical ways to synthesize andrographolite. Okay, and then just to show you this role, how this filter is actually working, I'm going to go into the reference detail. Okay, we have here andrographolite, and then you can see that we have the biosynthetic preparation role assigned to this compound for this reference. Okay, all right, so let me go back to our answer set. And then just to maybe show you a different compound. So for germanium oxide, the same thing, if I go into the substance detail page, I will be able to see, different types of information related to this compound. If I open up the references, okay, because now germanium oxide is obviously a very different type of compound than andrographolite. We have the substance role as well, but it'll be interesting to see how the types of common roles for that compound differs from compound to compound. Okay, so for andrographolite, we saw things like therapeutic use, pharmacological activity as the top few roles, whereas for germanium oxide, you can see the one of the common roles is technical or engineered material use. So which means this germanium oxide could be used in technical or engineering type of application. So it could be, for example, in batteries, in a coating, etc. Okay, and then we also see the catalyst use. So we know germanium oxide is also frequently used as a catalyst. And then another interesting one is nanoscale. So, this is if you're interested to find literature on germanium oxide where, people are doing, looking at it as a nanoparticle, nanomaterial. Okay, so different types of compounds, when you cross over, you get to see different types of roles appearing more commonly than others. Now, if I go back again. Okay, so this is searching by substance name. Now, if you want to do a search by structure, then you can open up the drawing editor here, okay, and draw out the structures from scratch. Now, I will introduce the drawing editor in a minute, but I would like to do a structure search on andrographolite, which has quite a complex structure. So instead of having to draw this from scratch, I'll actually just make use of the structure image. Okay, click on edit structure, and this automatically helps me add the structure into the drawing editor. So if you're working with some more complex molecule, even if it doesn't exist in the database, if you can find something similar, you can always add it in and then make minor modifications. So for the structure search for this example, I'm just going to use this. Okay, so assuming we've drawn this out and you want to check, right, if it's novel. So you can put the structure in and then just pretty much click OK and run the search. So when we put in a search for a structure, it will give us three types of answer set, okay, as drawn, substructure, and similarity. So of course, if you get 0 hits for as drawn, this means that your compound is novel, right? No one has reported it in literature. Sometimes you get 0 hits as drawn, but you may get some hits in the substructure, which means the specific compound that you've drawn does not exist, but there is something that is structurally very similar that's already known in the literature. All right, so let me explain what are the 3 different types of searches. So as drawn is, of course, compounds that match exactly the structure query that we have put in right over here. So this is taken from andrographolite. So we definitely we find andrographolite as an exact match. Then you might be wondering, why are there, there are 28 hits in total, but right now I'm seeing 14 because I have applied a stereochemistry filter. So these other compounds that we are seeing here, they are multi-component substances where one of the component is actually andrographolite. Okay, so this is andrographolite combined with something else. This is the salt form of HCl salt for andrographolite. So therefore, it has a different CAS registry number. So it's a unique compound, but one of the component matches andrographolite exactly. So it's an S-drawn. So you can see these are all the multi-component substances. Okay, so if you do an S-drawn, you will find things like multi-component substances, salt forms, even isotopes, right? They will all fall under the S-drawn bucket. The substructure is the one that is, more interesting because now you can see, all right, so I have limited my answers just to show you to, actually, let me get rid of this. I can limit it to an absolute stereo match because this has multiple stereo centers. So we have andrographolite, and I think this probably, okay, no. Okay, andrographolite, and then you start seeing, let me zoom in. Okay, what I mean by substructure. So this is andrographolite. So this compound here, the part that is highlighted in blue is exactly andrographolite, but this is some minor modification at the 2 alcohol groups here. Okay, and then this has an additional substituent at one of the alcohols again. So this is what we mean by a substructure. So although it's not exactly andrographolite, but it contains the structure of andrographolite plus additional substituents. Okay, and then if I scroll down, you'll start seeing, all the different minor modifications to the andrographolite core structure. So this is substructure search. Now the other one, similarity search. Similarity search, you'll see some overlaps with the substructure as well as the S-drawn, but there are also unique answers in the 3rd answer set. So for the compounds that you see the blue hit highlighting, so this is something that you will also find in the substructure, right? Because it contains the andrographolite structure just with an additional substituent. And then for the rest that do not have blue hit highlighting, it means that they are structurally similar, but they don't actually contain the structure of our query within the molecule itself. So for the similarity search, it actually uses a Tanimoto algorithm to determine the similarity. That's why you can see a score assigned to each of the compounds here. Okay. So, so substructure search is good for finding analogs, right, of maybe a natural product or a compound that you're interested in. Similarity search will help you to identify similar compounds, but do not have the same exact skeleton as our structure query. Okay, so if we have like a large answer set here, how do we know which are the ones that are more relevant to our needs? So again, we have different filters, right, to help you narrow down the substances according to what is it that you are looking for. You could filter them by molecular weight, by a certain type of property, or by their bioactivity that they have been associated with. Or you can also use the reference role button. So there is, for example, if you want to see which ones in the answer set actually come from natural products, we do have a natural product occurrence role. Okay, so if I select this role filter, then I know which of the ones in my answer set have been isolated from a plant before. Okay, so these will be the ones that have a natural product occurrence role, and we can click on the references here to find those papers where they have maybe reported the isolation of the compound from whichever plant. All right, so this is structure searching. Okay, now I'm going to move on to reaction searching. So let me again go back. Okay, so yes.
I'm sorry. I think Prof. Nanik got another questions.
Okay, sure.
She was asking if they do publication on a novel compound in one of the journals indexed by Scopus and others, is it automatically that their compound can be found in CAS?
Okay, so this will depend if that journal is indexed by CAS. Yeah, so this will depend. Because I wouldn't say our journal coverage and Scopus is like 100% the same. All right, so there could be references indexed by Scopus that is not covered in CAS. So the key requirement will be that it needs to be a journal that's indexed by CAS.
Okay, thank you.
The question. Okay, so for example, right, if you do maybe run a search in Scifinder N and then you don't find your compound, and then you can double check to see if that journal is indexed. If it's not indexed, you can also write into CAS to suggest to our analysts, to the editorial team, to include this particular journal into our Scifinder N database. Okay.
All right, thanks, ma'am.
Okay, so all right, so moving on to reactions. So the next part would be looking specifically at how to synthesize a compound. Again, there is the option to search it by name, so you can put in your target molecule by name, or we can also put in our target molecule by structure. So again, I will begin with the easier option, which is to put in the name. So I'm going to use, say, gefitinib. Okay, run the search, just put in the compound name, run the search, and it will automatically find reactions where gefitinib is either the product or the reactant. Okay, so again, we have the substance role filter to limit it to the type of reactions that we are interested in. The other way is to just add in the word synthesis. Okay, so if you do it this way, we will assume that you are looking for reactions to synthesize gefitinib. So you can see that the reaction role filter has been removed, and all the reactions that we see here will be where gefitinib is the product. Okay, so the reactions are grouped by scheme. So you see here scheme 1, right? scheme 1, it's using this starting material plus this starting material to give us this product. If I move to scheme 2, it's the same product, but using different starting materials. So this is considered a different pathway to get to our desired product. And there is a number behind each scheme. So this tells us how many examples of this reaction has been reported in the literature. So for this scheme 1, it has 17 examples of reactions reported, of this reaction reported in the literature. It can come from the same paper, it can come from a different paper. Okay, so we have shown 3 options here. Then we can click on view all reaction summaries to see all 17 reactions. So this is actually a very effective way to view reaction results. Once we have identified a pathway of interest, we can look at all the different options or all the different reaction conditions to consider. Okay, so typically for the reaction summary, you'll see things like reagents, what is the solvent used, what is the temperature, time, etc. And then you notice that for this reaction summary compared to this comes with additional link called experimental protocols. So whenever you see this link available, it's telling us that in Scifinder N itself, you'll be able to find the synthetic details. Okay, so I'm going to click on this. Okay, so this is the reaction summary table, and this is the details of the synthesis, which has been taken from this patent literature. Okay, let me go back. So there is actually a filter option available to help you find those reactions that come with available experimental protocol within Scifinder N. There are 2 formats available. The one that we saw earlier on is the experimental procedure, where it is kind of like a 1 paragraph of text. So both are useful information. So I would advise you to just select both, because there will be some that has this version and not this version, and then there will be some that have this version and not this version, and then there'll be some that have both. So the best way is to just select both options. But just to show you the difference between synthetic methods and experimental procedures, so I'll select just one of it now so that I can show you the difference. Okay, so the same thing, I'm going to click on the link here. So this is synthetic methods. So you can see it's a slightly different format, all right, but it's also the synthetic details. And in this case, because the original document reported chemical shifts, characterization data, so we have included it in Scifinder N as well. All right, so this is one format, synthetic methods, versus the other one, which is experimental procedure. But they're all useful synthetic detail information. Okay, so let me go back here. Okay, so this is searching by a reaction by the keyword, all right? So there is also the option to put in a chemical structure, right? So let me get rid of this, and this will require the same drawing editor that we saw earlier on. So let me open this up. So now I will do a quick introduction of the drawing editor. It's very similar to most chemical drawing software such as ChemDraw. In fact, if you have already structures drawn in ChemDraw, you can save them as a mol file. We have an import button here. You can import it as a mol file, or you can convert your structures into a SMILES string and paste it here to convert it into a structure. The last option would be just to check if your ChemDraw version has the Scifinder N add-in. So if it is available, you can actually launch a Scifinder N search from your ChemDraw software. Okay, then of course the last option is to just draw it out from scratch using the tools here. Okay, so a quick orientation of the drawing editor. Commonly used ring systems are found here. So I'm going to select the benzene ring, just move my mouse to the drawing space and then click to edit to the drawing space. I have a second 6-membered ring and I will just click next to it to fuse them together. So we have the commonly used elements over here. If whatever you're looking for is not found there, click on the C icon for the full periodic table, okay? So you can switch between the different elements to change any of the carbons to another atom. Or if you don't want to kind of, clicking and then switching back to carbon, you can also bring the pencil to the position where you want to replace it with, for example, nitrogen, and type N on the keyboard, okay? So I didn't have to switch to N by clicking here. I just moved my mouse to the position and I typed N on my keyboard. So in this way, I can continue drawing. If I want to attach another bond to one of the atoms here, you just have to left click on the atom, drag out the bond. You can see now I have the bond drawn out, and then release the mouse and the bond will be attached. You can repeat the same for the next bond, okay? And I'm just going to add in another 6-membered ring. If I want to insert a double bond, okay, I can again use the double bond feature over here, or I can always just stick with the single bond. Okay, I can draw out my single bond first and then click it a second time to convert it to a double bond. I can click it a third time, it becomes a triple bond, and then it will go back to a single bond again. All right, and I'm going to replace this with an oxygen. Okay, so with this structure, you can actually either do a structure search or even a reaction search. All right, it depends on what you select here. Okay, if I want to do a substance search, I can just switch it using the same structure. Okay, so right now we're going to do reaction. Okay, so I can run the search this way, and it will give me reactions where this is either the reaction or the product. So I can go one more step and be more specific and say, well, just show me reactions where this is the product. So I add a reaction arrow to the left-hand side. It is automatically assigning our target molecule as the product. Okay, you don't have to, but doing so, you will then only see reactions that are trying to synthesize that molecule. Okay, right? Or else it will ask us again to choose the reaction role that we are interested in. So this is our target molecule. Okay, and this is one way to synthesize it. This is estron. So because now we have used a structure for reaction search, we also have the substructure option. So the definition of a substructure here is exactly the same as earlier on when we looked at the structure searching. Okay, so I'm going to switch to substructure. So what we see first are still the estron. If I scroll down further, we'll start seeing the substructure answers appearing. Okay, so this is the first example of a substructure. So hopefully you can tell why this is a substructure. Okay, it has our target molecule, but with an additional methyl group over here. So a substructure search is useful if, for example, you are trying to find reaction conditions to synthesize something you're working on. Maybe there isn't any match, okay? Or maybe there's only 1 or 2 hits and you like to have more options. So something like this, although it's not exactly the same as your target molecule, but it's a small modification. So the reaction conditions may still work for your own target molecule. Okay, so this is the usefulness of also considering substructure hits. Okay, So other than experimental protocols, there are other filters that we can use to help us narrow down reactions, especially if we have quite a lot of hits. You can filter them down by yield, prioritize by yield. Non-participating functional group is if you have a certain functional group in your molecule that is sensitive to certain type of conditions. So you want to make sure that they are not affected by the reaction conditions. So you can choose those reactions where it doesn't affect any of the functional groups listed here. Reaction notes is also a useful one because you can quickly find reaction conditions that are using maybe certain synthetic approach. By that, I mean things like maybe a solid supported catalyst. Maybe you want to find reaction conditions that use the microwave, or they do using a green chemistry catalyst or green chemistry reaction conditions. All right, so this will be a quick way to identify those reaction conditions. Okay, so this is searching by reaction structure. Now I'm going to modify this structure a little bit. Okay, and let me get rid of this and add this in. So sometimes when you may be trying to find reaction conditions for something and you notice that, if it's not available in Scifinder, and meaning no one has actually reported a synthesis for it, what can you do next? Okay. And I'll introduce another function in our drawing editor, which is the shortcut menu. So there are certain functional groups and moieties that have been pre-drawn for you, so you can just quickly edit. You don't have to draw the full group out. Okay, so I might be searching for this as a product, right? Hoping to find some examples of reaction conditions to synthesize this. I click OK. All right. And you also notice that when I put in the reaction structure, a reaction search by structure, the retrosynthesis plan button also pops up. Okay, but for now, I don't want to use this yet. I just want to see if there are any conditions or any reported reactions for this. So you can see in this case, it doesn't find any hits. Okay, so if it doesn't find anything that matches your structure query, not even a substructure, then it will prompt you to try the retrosynthesis plan option. So I'm going to click on this. So although this, no one has reported a synthesis for this compound, but our retrosynthesis planner will try to suggest ways or ideas that you can use to get to this compound. So these are the options for the retrosynthesis. This is the synthetic depth. How long a synthesis do you want? We can have up to 4 steps. I'll just leave it as 3. This is to determine the type of predictions that you see. So obviously this is not known in literature. So we will be looking at predicted reactions. Our predicted reactions are based on chemistry rules. So you can choose for predictions that are based on common chemistry rules, or if you want to also include predictions that are using less common types of chemistry. So I'm going to stick with common for this, and you can also change the starting material cost that you have. The default is just 1,000 USD per mole, and you can choose to be notified via email when the plan is completed. Over here, you can select which part of the molecule you want the disconnection to take place first, and you can also protect certain parts of the molecule. So we'll just leave all this as it is and just run a plan using the default settings, okay? So compound not known in literature, we need some ideas, or just, this is also a good tool to help us plan a synthesis. We can probably think of the ideas on our own, but then we'll need to also search each idea individually to explore what is feasible and even to use what reaction conditions. So you can see that it's generating the result. So typically, if it's a predicted result, it will take a while to load. So you can just leave it to run in the background and do your other stuff. I'll go into my history to pull out something that I have run in advance. Okay, so looking at the retrosynthesis result. So this is the one that we are generating right now. So I should have run this previously. Let me take a look. Okay, so is it this one? Okay, it's not exactly the same. I didn't have a nitrogen here, but let's just use this as an option. Okay, so this is also not known in literature. Okay. All right, so this just has an additional nitrogen. So you can see here, this compound is not known in literature. No one has reported a synthesis, but we help you to put together a plan. And in fact, after this step, this step here is not known in literature, but from here onwards, there is actually reported synthesis. So you can see the retrosynthesis plan can be a combination of predicted chemistry, experimental chemistry, and predicted chemistry. So the purple color would mean an experimental step, and the green color would mean a predicted step. Okay, and this is not the only plan that it has come up with. If I go into the steps tab, you can see for each step what are the number of alternatives that you can consider. This is for the first disconnection step. If I move on, okay, you can see that there are many alternatives that you can consider. And you can go in to look at the alternatives and make changes to the plan. Okay, so I can either click on alternative steps here or click on the flask icon. This will bring us into this alternative steps window. Okay, so this is the step that we currently see in our plan. So I can scroll down to look at different ways of disconnecting this molecule. Okay, so you can see here. So if you find something, another approach that you think is more useful or something that you prefer to try first, we can always replace it. So maybe I'll just pick this one. Okay, so if I click select, it will then replace that step with the new one that we have selected. Okay, and it will recalculate the new estimated yield and price for the modified plan. And if the disconnection results in a new intermediate, which I think it has, so it will also update the subsequent plan. Okay, so now we have some changes in the steps behind as well. Okay, and the next thing that people typically will ask, well, so if this is a predicted step, no one has done it in the literature, no one has reported it, how do I know what reaction conditions to use? This is where the evidence comes in handy. So although it's a predictive step, there is over 900,000 examples of evidence. So the evidence in this case would refer to reactions that are performing the same type of chemistry, but not necessarily, but not the exact intermediates that we see here, because it's predictive, right? So it won't be these true starting materials. So what we can do is to just open this up. All right, and then this with 900,000 is of course a lot of reaction conditions. So you can see these are different starting materials from our intermediates in our scheme, but it's the same type of amide bond formation, right? We have the aniline, and then different ways to form an amide bond. Okay, so of course, we have over 900,000. We can definitely filter them down to maybe the ones that are closer to our type of molecule. So maybe we can limit it to aniline type of amines rather than this sort. So I can go into search within results. Okay, and say, well, show me only the ones that involve this sort of aniline as the starting material. Okay, so it will search within my current answer set. I will search as a substructure so that I will find the reaction conditions. All right, that is, at least has this portion that is similar. Okay, this is part of a bicyclic. All right, so we have this type of amide formation for this type of aniline, so that the reactivity may be more similar to our starting material. Okay, so of course, if it's a experimental pathway, then the evidence in this case, the evidence will be the exact starting materials that we see here. All right. Now, earlier on, we saw that we can protect and block certain, protect and break certain bonds, right? So maybe I say, well, I would like to break the bond here instead of here. Okay, the first disconnection, I want it to happen here. No, maybe I should say I want it to happen here. Okay. All right, let's just choose here. Okay, and then I say, well, let's protect this part of the molecule. So this is setting some limitations or criteria to the type of pathways the system will suggest to you. All right, so again, you have to rerun the plan if you introduce any changes. So let me just quickly go into the history because it's going to take a while to run. Okay, this is the one that is generating. Hopefully I have something that is this way. Okay, so this is run previously, so I can open this up. So this has the restrictions that we have applied. Therefore, earlier on, we had to change the first step to this amide type of formation. But now, because we say, I want the first disconnection to happen here. Okay, so it automatically shows us just this type of pathway. And if we go into the alternatives, it will be all this sort of disconnection. Okay, and then because we choose to protect our bicyclic ring, you can see that it doesn't break down this ring further, unlike in, this is the one that we ran earlier, unlike in the previous plan where you see that it actually breaks this down to simpler building blocks. Okay, so that is the use of the bond protection and the bond breaking function in retrosynthesis. Okay, so this is for reaction searching. Again, let me just take a quick look, see if there are any questions. Okay, no questions. And then finally, for the last bit, just in case if there's anyone in the audience who is interested in sequence searching, I'll just do a very quick demonstration. So the biosequence search here is actually doing a BLAST search, which is similar to the NCBI BLAST search that you can access publicly. So you can paste your sequence into this box here or upload the sequence that has been saved as a text or a FASTA file. So I'm just going to upload a sequence. Okay. Let me see. Okay, I'll just pick this one as an example. I'll pick this one. All right, so I have here an amino acid sequence. So the alphabets here, right, is the amino acid code for the different amino acid. It's a protein sequence type, and I would like to search in the protein database, and I will set the maximum number of results allowed. Under the advanced biosequence search is where you can vary the parameters of the BLAST search. I'll just leave it as the default settings and then just hit on the search button. Okay, so the search is immediately submitted, and then you can see it appears in our search history and it's already complete. So I can open this to view the results. Okay. So so you will see the results right now is sorted by subject coverage. You can always change to different types of sorting. So the first hit that we see is actually an exact match, okay, because it's aligned across 143 sequences with 0 mismatches. Okay, so this is the alignment. It tells us how our query sequence aligns with the hit that is retrieved from the search. The subject tab will tell us the identity of the subject sequence, which is the identity of the hit sequence, and references will be the literature where this specific reference, this specific sequence has been found. Okay, so there's quite a lot of literature actually linked to this. In the second example, all right, is where we have a match, but there is at one position where the position of where the type of amino acid is different. So you can see there's this pink color here, right, to tell us that there is a misalignment, and we can see there's one mismatch. And in the alignment diagram, you will see exactly which is the amino acid that is misaligned, okay, and then so on and so forth. All right. So for each individual reference, each individual sequence, you can pull back the literature. All right. So let me just go back. All right, there's a reference button. I can pull back the literature for this sequence itself. All right, so 154 references just for this sequence. And you can see that it's a mix of journal and pattern. Okay, there is also another reference button at the top. Okay, and currently at the moment, for non-pattern literature, you have to use the individual reference button in order to pull it back into the reference answer set. If you use the button at the top, which is of course more convenient because you can pull back the references for all your hits here, you will see that it only pulls back the pattern document. All right, so this is something that will be coming up in a future enhancement where we will allow journal documents to be pulled back as well if you use the reference button at the top. Okay, so this is just temporarily. The function will be coming up pretty soon. And so for the individual references, if you click individual sequences, if you click on the reference button, you'll be able to retrieve journals. Okay, so just to let you be aware. So in case if you hit on this and then you're wondering how come I only get pattern literature. Okay, so this is a quick demonstration for BLAST search in Scifinder N. And this concludes my demonstration. So let me see if there are any questions. So no questions at the moment.
Yeah. Okay. Thank you, Ms. Pamela, for the quick demonstration, for the explaining, so that now we can discuss. Okay. Let me to before let me to a demonstration about how to what the step the just finder in remote text with remote text. Any participant here to ask Miss Pamela? Or we discuss something? Okay, I will read the conversation at the chat column. Okay. Okay, now I will tell the participant here which one the step we can access Skyfinder, how to access just Skyfinder in with remote text. Okay, let me to share screen now. Okay. Baik, okay. Bapak Ibu, teman-teman dari Fakultas Sains dan Teknologi, dari Fakultas Farmasi, kemudian mungkin Fakultas Teknologi Maju, begitu, ya. Setelah tadi Miss Pamela explaining all of the tools yang ada di Skyfinder, hari ini saya coba untuk menunjukkan, ya, sebelum Bapak Ibu untuk bisa mengakses cas Skyfinder tersebut, Bapak Ibu dipastikan untuk sudah memiliki account remote text-nya yang sudah terregistrasi, sudah bisa dibuka, sehingga tampilannya sama seperti saya saat ini. Nah, kemudian Bapak Ibu harus make sure kalau Bapak Ibu sudah melakukan registrasi link di sini, ya, this one, ya. Registration link, kemudian dia tertampil seperti ini. Nah, kemudian Bapak Ibu coba untuk klik next, kemudian accept, kemudian oke, baik. Kemudian diisi, ya, diisi first name, last name, email address, pastikan membuat dengan afiliasi UNER, ya. Email address-nya. Nah, kemudian di sini nanti Bapak Ibu klik register. Kemudian Bapak Ibu setelah klik register, lari ke email Bapak Ibu yang telah didaftarkan tadi. Nanti akan ada email balasan dari Skyfinder Registration bahwa kita sudah komplit Skyfinder Registration, begitu ya. Kemudian kita klik link yang ada di sini. Setelah kita klik, kemudian nantinya Bapak Ibu bisa coba akses tanpa membuka kembali remote text. Jadi kita buka di new tab, begitu ya, tetapi di belakang cas.org ini, cas.org ini tidak perlu ada unerremotext.co lagi, begitu. Jadi nanti kalau misalnya Bapak Ibu buka kembali di sini, di Skyfinder ini tidak bisa diakses, tetapi Bapak Ibu langsung membuka tab baru ke sini, ya. Oke, di sini tanpa ada remote text uner.co, kemudian Bapak Ibu turun, kemudian kita lakukan login. Nah, di sini kemudian nanti bisa dipastikan kalau sudah loginnya sudah benar, ya, nanti akan tertampil halaman Skyfinder seperti ini. Ada pertanyaan Bapak Ibu sampai di sini? Monggo Bu Nani atau Bu Dewi dari farmasi, nggih.
Saya coba dulu, Mbak.
Oke, baik Bu Nani, nggih. Baik, ngapunten nggih Bapak Ibu, para pimpinan di fakultas yang hadir sebagai partisipan hari ini. kami menginformasikan apabila nantinya Bapak Ibu berkenan untuk menjadikan training hari ini sebagai salah satu yang kita langgan di remote text gitu ya, yang dijelaskan oleh Miss Pamela dan juga Mr. Adran tadi tentang Test Finder. Kalau berkenan ini akan dilanjutkan setelah trial, kita akan melanggan. Nanti dimohon Bapak Ibu para pimpinan untuk mengirimkan surat untuk kurang lebih isinya mengenai untuk berlangganan Test Finder yang ditujukan kepada Kepala Perpustakaan Universitas Airlangga. Begitu. Nah, hal itu nantinya akan kami jadikan fondasi kuat begitu agar Skyfinder ini bisa kita langgan dan kita bisa maksimalkan bersama sebagai penunjang Bapak Ibu yang ada, penunjang belajar mengajar Bapak Ibu yang ada di Universitas Airlangga. Ngaten nggih, bisa dipahami ngaten nggih, atau ada yang ingin ditanyakan kembali?
Suratnya dalam waktu dekat ini atau menunggu setelah trial selesai, Mbak?
Boleh Ibu, setelah trial selesai, boleh nanti kita evaluasi begitu setelah trial, kemudian semakin mantap dan berminat nanti bisa langsung ke Ibu Kepala Perpus. Nanti nggih Bu Nani ini.
Oke, insya Allah nanti kami sampaikan ke pimpinan.
Baik, nggih. Begitu nggih Bapak Ibu, mungkin dari Fakultas Farmasi atau Fakultas Kedokteran, Fakultas Teknologi Maju, mungkin di sini yang relate begitu ya dengan keilmuan yang sedang digeluti. Seperti itu. Nanti jika ada pertanyaan mengenai untuk bisa akses trialnya, atau mungkin kesulitan ketika belum mendapatkan konfirmasi atau seperti apa, atau belum bisa login dengan baik, begitu nanti bisa menghubungi saya atau Bu Nurma. Ngoten nggih?
Ya Mbak Indah, nanti di trial dulu oleh formasi, nanti kami kirimkan surat kalau memang dianggap sangat bermanfaat ya.
Nggih, terima kasih Bu Dewi. Nggih. Oke, Mr. Adran, Miss Pamela is done for me. Ini kita Oke, Bu Nani, ada pertanyaan di kolom chat atau langsung disampaikan?
Sudah tadi.
Bu Nani.
Saya sudah dijawab 2 tadi pertanyaan saya ya, Dr. Lin ya.
Oh, barangkali ada question lagi begitu Ibu, mboten enten? Tidak ada.
Enggak ada. Kita akan coba dulu, nanti kita akan sosialisasikan ke mahasiswa, semoga banyak sehingga nanti bisa dilanggankan. Ya Bu Dewi ya.
Ya Bu Nani.
Okay, Mr. Adran, what's next? Done for me.
Okay, thank you, Bu Indah. Yeah, I think we have done the training as well, and then thank you all for the time to attend this training, and then thank you, Pamela, for your time to show them all the details on how to search and navigate around Scifinder N. So I hope that during this 3 months trial, everyone can fully utilize Scifinder because all the features are actually in full. You can try to use as much as possible and then try to evaluate it. And then after the trial, I will actually write an email to everyone to gather your feedback. And then if you have any suggestion or recommendations, feel free to write to me. And then I will actually recommend it to Bu Indah and Bu Nurma and also Unai Library, so that hopefully if everything is successful, then probably you all can budget in for the subscription in the future. Then yeah, we will discuss that accordingly. All right.
Yeah.
So if you have any questions, I actually written down my email and also Pamela's email. Feel free to write to us if you have any technical questions or you face any difficulty on how to utilize the features. Yeah, then we will help you to address it accordingly. All right. Okay, thank you. Thank you so much, everyone.
Thank you, everyone.
Thank you. Have a nice day and then stay safe. Okay.
Yep, have a nice day. Take care.
Take care. Bye-bye.
Bye.
Bye.
Terima kasih. Bye-bye.
Baik. Terima kasih Bapak Ibu atas partisipasinya hari ini. Semoga nantinya training hari ini bisa bermanfaat dan kedepannya kita bisa melanggan Scifinder sebagai bagian dari support system kita dalam menunjang riset di Universitas Airlangga. Baik, terima kasih. Saya akhiri. Selamat siang. Wassalamualaikum warahmatullahi wabarakatuh. See you, Mr. Adran, Miss Pamela.
Thank you.
Thank you. Bye-bye.
Thank you, Bu Indah. Thank you, everyone. Bye-bye.
Dr. Pamela.
Thank you,
Thank
Prof.
you.
Nanik. Bye-bye.
Bye.
Mbak Indah. Bu Dewi.
Bu Nani, matur nuwun sangat. Bu Dewi, matur nuwun sangat.
Prof. Nani, terima kasih nggih sudah diajak ini koleganya.
Matur nuwun Bu Nani, Bu Dewi sudah merapatkan teman-teman untuk bisa hadir hari ini.
Terima kasih.
Matur nuwun, tadi ada Prof. Mirta, nggih, matur nuwun.
Thank you, Pamela. Thank you, Adran.
Thank you. Thank you. It was my pleasure.
Thank you. Thank you. Bye-bye.
Thank you.
Bye.
Bye.
Take care. Bye-bye.